Here are some additional examples from 8.3, and we're going to try this using the geometry software. Okay. Maria gathers 3 pieces of wood, 16 feet, 30 feet, and 10 feet. Can she make a triangle with these wood pieces? So when you click to the next page, it just automatically says no, because when you add up the 2 short sides, it's not long enough to pop up when you couple it with the third side, or we triple it with the third side. So I want to show you what this looks like if you use the software. So we're going to go to the math tools. We're going to click 2D geometry, and it is a triangle, but we're going to be building this triangle. So I'm going to build a figure. Okay. Now that I'm here, now everybody keep in mind, I practiced this. So that's the only reason why I'm not going to mess up as much as I otherwise would. So cut yourself some slack. Here we go. Show the grid. I want my grid to actually be smaller, so I'm going to zoom out just a little bit because one of my sides is supposed to be 30 units long, right? So here I go. I'm going to draw a side, a segment, because I want it to end, and I'm going to draw a segment that's this big. I'm going to draw a segment that's this big, and I'm going to draw a segment that's this big. So I want my first segment to be 30. So this tool here is called Inspect. Inspect is what tells you how long something is or how big an angle is. So I'm going to click Inspect. I'm going to inspect that line, this line segment, and this line segment. And I'm going to position these a little bit better. And I'm just going to kind of keep my eyes on them. So here we go. I'm going to click my select tool, my pointer again. So I want this guy to be 30. So I'm going to click on B and I'm going to drag it until it says 30. And I'm probably not going to be able to hit it. Whoa, there it was, right on the money. I am, what do you know? All right. And then my other 2 sides were 10 and 16. So I'm going to make this guy 10 as best I can. And I'm going to make this guy 16. Oops, as best I can. I'm just going to get close because that's just the way that this goes. All right, so I'm going to try to make a triangle, and I'm going to leave this long guy right here. I'm going to bring this guy over, and here's what I'm going to do. I'm going to put C, now remember this is the one that's 10 units long. I'm going to put C on top of A, and I'm going to move D so that it goes back to being 10 units long. And then this guy was supposed to be 16, so I'm going to move it. I'll move this one. I'm going to move it, and I'm going to try to keep it 16. So I'm going to put F on top of B, and I'm going to try to keep this guy 16. So the game is now we're going to try to manipulate this side and this side so that D and E meet each other to form a triangle while keeping this 16 the whole time. So if I keep moving it, there's 16, so I'm going to bring this one down. I want to keep it at 10. Okay, it's at 10. It's still not meeting, so I'm going to bring it down some more. It's still at 10. This one is still at 16. And here's the thing. They're not long enough. They're never going to meet in the middle. As a matter of fact, if you could get them to meet in the middle, what I want you to notice is that this funky looking triangle, if you add this, which is about 14, with this, which is about this one is 13.86 and 16.15. Just out of curiosity, 13.86 plus 16.15 is 30.01. So notice that 30.01 is still longer than 30. And if I bring them up even a little bit further, if you were to add those 2 together, 14.29 plus 17.85, this is almost 18. This is about 14. 14 plus 18 is 32. If I move it up even more, this guy's 20, this guy's 20, 20 plus 20 is 40. No matter what, when you add up the 2 shorter sides, they will always be longer together than the third side. And if they're not longer together than the third side, if they are 10 and 16, then what happens is you try to get them to meet and they don't. They end up falling totally flat and never actually meeting each other. If they did meet each other perfectly, then the two together would be 30. So once you figure out the shortcut for that, it's not so bad. On this one, 17 feet is the longest side, so when you add these two together, they better be more than 17. 10 plus 11 is 21. That's more than 17. This will make a triangle. See? I told you. So this last one is a thing in the toolbox that I kind of want you to see because it's sort of interesting. We're trying to make two different triangles where they have two side lengths that are 6.5 and 5.5, and they both have a 95-degree angle that's not formed by those two sides meeting. Watch what your toolbox can do. If you go here to Math Tools, the lawn's getting mowed. Sounds like spring, doesn't it? And we go to two-dimensional geometry, and we're going to go to triangle conditions. So this is a cool one because you can compare two different triangles. So I'm going to click Compare Triangles, and I'm going to compare triangles where we know two sides and an angle that's not included. This guy is two sides with an angle that is included. That means it's in between the two sides, but we don't want that. We want two sides and an angle that's not included. So here we've got, they're talking about this side. I know they're talking about those two sides because they're marked, and this angle A that's not included. So A and D are the same. This side and this side are the same, and this side and this side are the same. And as you can see, those two triangles, if you rotate them around, they're not going to fit on top of each other. I mean, maybe they would. Like, let's see. Let's see. We'll go Show Table. Show Table. So here is an example where they're close, but they're still not the same. So it said it was one side was, I don't know if we can actually do this. One side 6.5, one side 5.5. So let's see. Let's try to make AC 6.5, 6.5. So on both of them, AC should be 6. AC is 6.5, and the other one with two marks is DF. DF is 6.5. BC, they wanted us to make it 5.5. I don't know that I can. That's as big as I can make it. But even so, BC and whatever this one is, whoops, are both the same length, and here is this angle that's not included. Here's how you can tell if they're the same or not. Look at the third side, AB and DE. Are they the same? Here's AB, 5.04, and DE, 5.25. Those are not the same. The other ones are exactly the same as each other, but those are not. And in the angles, they still have that one angle that matches, but the others don't. So when you have two sides and an angle that's not included, maybe the triangles are exactly the same size, but maybe they aren't. So that's one of those situations. My point is, I want you to be able to see how this tool works when you're comparing two triangles, because it's actually kind of handy. This last one, example 5, I didn't do in the other video. This example 5 is interesting. A couple of you have brought this up. Somebody from both of my classes has brought this one up. Can you draw more than one triangle that has angles that are exactly the same size? So here's a 30, 60, 90 triangle. They didn't tell us anything about the side lengths, so you can make this one any size you want as long as the angles are 30, 60, and 90. When you look at the next figure, this triangle also has angles of 30, 60, and 90, but these two triangles are clearly not the same exact matches. So knowing that 3 angles of one triangle are the same as 3 angles of another is not enough information to build triangles that are identical. 1 second, I hear my name. Yes, I will turn on Minecraft.